Hi, we're Gregory Stretchkov,
Nicolette Benora,
and Lauren Stretche.
all engineering students at Hopkins High School in Massachusetts, in 10th and 11th grade, and our invention is the EcoTurbine.
In our community, we observed that we've had a history of having pollutants in our water. This resulted in water fountains in schools being turned off, people being advised not to drink their tap water, and a lot of people having their water tested and finding lead. Other communities have had similar issues with their water being contaminated.
We have researched the statistics of lead and other contaminants in Massachusetts public schools. We have found that according to an article from Harvard that out of 1,847 schools, only 511 actually tested, and that 248 schools out of the tested schools reported that there was contaminated water. This is nearly 50% of schools that have found contaminants in their school's water.
Our invention is a water turbine that filters and tests water as it spins, creating energy. Our design is scalable and can be fitted under different circumstances. For larger water sources, we'll use a larger turbine, focusing more on generating power rather than filtering the water. On the small scale, we would like to filter the water instead of generating power.
During our research process, we did not find anything that combined the aspects that our invention does. We overcame many challenges through our design process, including reprinting, rewiring, and retesting our concept until we fine-tuned it to work exactly the way we wanted it to. We reprinted the piece that holds the motor 2 to 3 times before we could get it exactly the size that we needed. We also had some issues figuring out the correct calculations that we needed to see how much energy we could generate using the system.
Our testing started with 3D printing the water turbine and spinning it on a skewer with compressed air to test if it would spin, and then we tried attaching it to the DC motor to see if it would spin, but we had some issues with getting it to stick, so we decided to use hot glue on the edges. We then tested it by placing it into the holding area to make sure that it would fit, and once we were sure that all of that worked and we tested it with compressed air for water, we finished off the physical building part, and then it was time for the electronic portion.
The EcoTurbine is powered by a built-in turbine designed to handle high-pressure water, which turns the shaft of a DC motor, generating electricity, with a process called electrical induction. As the DC motor spins, it generates roughly 1.5 volts, which feeds into a rechargeable battery. The onboard microcontroller needs an outside power source, so we solved this by having some of the power generated from the turbine go back into the rechargeable battery. The microcontroller on the EcoTurbine is responsible for testing the water. If the water is highly conductive, it means there may be pollutants in the water. This is because pure water cannot conduct electricity. And if the water conducts electricity, it means that there are particles in the water that do not belong there.
Our system produces at least 1.5 volts of electricity on a small scale when tested using compressed air to spin the turbine. With larger scale models, the power generated will increase to calculate how much voltage can be generated on larger scales. Faraday's law can be used. Faraday's law is to demonstrate the voltage generated from electromagnetic induction, which is the change in magnetic field.
Through the design, test, and build cycle, we learned that we would not go through the cycle just once, but at least 3 or 4 times before we could get our prototype to the point where it accurately displays our concept. We knew that we had to persevere and not give up, even when we were frustrated or had to redesign and rebuild something, because the results would be worth our time and effort.
To demonstrate our model, we have 3D printed a small scale version. Here we have our water input, here we have our DC motor, and the turbine that spins, and a filter. This can be attached to the microcontroller and the battery through a diode which runs into the battery, making sure there's no backflow into the motor, recharging the battery, powering the microcontroller. There are 2 LEDs on the microcontroller, one blue, one green. Blue means there may be pollutants in the water. Green, it means that the water is clean. We test the conductivity by having 2 wires connected to each other. If there's a circuit between them, that means that there is conductivity, meaning that there could be something in the water. If the circuit is cut, that means there's no conductivity in the water and can simulate that the water is clean. As you can observe, that it changes when the circuit is complete or disrupted. We can test how much power is generated by using a voltmeter, which can measure how much power is roughly outputted when the turbine is spun. As it spins, you can see that some values appear, but not in great numbers, as we cannot spin it fast enough to generate any real power. But in real life, the water pressure, or the water going through the turbine, will generate enough RPM to generate enough power. To use our invention, it will be placed into a pipeline, but here we have an open-sided model. For materials, we use PLA Plus to print the components such as the turbine, structure, and the parts on the device. On top of the 3D printed components, we use a 260 DC motor, an Arduino Uno powered by a 9-volt rechargeable battery with a jumper wires, resistors, LEDs, and a diode. and a breadboard that puts everything together. To build the parts, we use hot glue and electrical tape to secure everything was into place.
This solves the problem of needing a cleaner way of producing energy while also making sure that the water is clean. We want to keep our planet in a cleaner place, and this is the best place to start through finding cleaner energy sources. We believe that everyone should have access to cleaner water, and our invention helps through ensuring through our layered carbon filters and our water testing system. Having a filter and a testing system together keeps things effective, efficient, and simple.
In the future, we'd like to make our recyclable turbines out of recycled plastic from the ocean to help with pollution, while still keeping the turbine strong. For example, a large-scale turbine was designed to fit the outlet or inlet pipes of a water tower that would be 500 millimeters. A turbine fitted to that size would probably be made out of 5 to 10 pounds of plastic, and that would be removed from the ocean with every tower brand we produce. We would also like to have the testing system connected to people's mobile devices so that if the light does turn blue, they would be notified right away. We would also like to look into more specialized filters that can filter more without being need to change as frequently.
Our target audience is anyone who would like to use cleaner energy while also testing and filtering the water. We believe that the EcoTurbine can make a big difference in the world. We know that it can help a lot of people. Thank you so much for listening. I'm Gregory Trechkov,
I'm Nicolette Benora.
And I'm Lauren Stretche.
presenting the EcoTurbine.